Okay, so we are starting our Unit 3. This is programming stages. And in programming stages, we'll be specifically looking at requirements, or what we call specification, be looking at design, coding, then testing. We have documentation, deployment, and maintenance. So, a software development, or what we can call as programming, goes through different stages, and these stages can be grouped differently by different authors, but basically they are talking about the same thing. So the first one is what we call specification. When we are programming, we are coming up with a program, we start with specification. We look at what specification is, then we go into design. After you have designed, then you start the coding. So we haven't yet started coding yet. We are still just looking at some basics of programming or introduction to programming. But later we are going to be introduced to how we can code. Then you have testing, then documentation. Documentation, some authors may not have documentation as a separate stage or a separate phase. But we have included it here so that we can have a discussion specifically for documentation. We have taken it out of other phases so that it would go together with. But maybe other authors, you are going to find it under deployment. Others may have it under another phase, or they may say this is an ongoing phase that may span through many phases. Whichever the case, we have included it here so that we can have a better talk about documentation in our presentation. Then we have deployment. Then lastly, there is a phase of maintenance. So this is what we're going to cover today. Let's start by looking at the specification. Specification is a definition of what computer program is expected to do. Before we create a program, there should be a need, and that need is described. When we have described that need, then we can have a specification trying to put it in such a way that we can come up with a program. We can come up with coding. So we are trying to address a certain problem. So we define that problem in specification, and we are saying is a statement of program requirements. So we identify the problem, then we come up with what we can do to achieve or to come up with a solution. So you come up with the requirements, what would be needed for us to come up with a solution to address this problem. So we say requirements. So specification can also be looked at as a formal statement. And this formal statement is a formal statement of conditions where later, after you have developed your program, you use your program and verify whether what you have programmed is correct thing or is addressing the need by checking it against the formal statement that you had under specification. So in general, specification is a requirement phase. It's a phase where you collect the requirements and you put them in a document that we call a specification document that actually details every feature the program is going to have and the other features that may not necessarily be functional. So there are two types of requirements. We have requirements that are functional, what the system must do, and we also have other features that are not functional. So these are just other features that are not necessarily in functional category. So we have these two types. So specification, you identify a problem, you come up with a formal way of presenting some requirements of what you want to be developed, and these requirements are in two forms. We have others which are functional and others which are non-functional. Specifications show input requirement, and you also show out requirement, storage requirements, and processes that will turn input into output. So when you are coming up with your specification, you specify what will be the inputs to the program. Where will this input come from? From the user, from another program, from where? And what will be the output? Reports or output statement that we may need to have from. After you get the inputs, the program is going to process these inputs. What will be the output from the program? And does the program need some storage? How is data going to be stored for this program? So you include all these requirements under specifications. And lastly, of course, how the input will be transformed into output using a processor. So the process requirements are also actually indicated under specification. So we are saying, if you cannot describe it, it means you cannot build it. So before you start building a software, the first thing is you should be able to describe it. You should have a statements that describes your problem you want to solve. Then you can start building. Okay. The second phase is that of design. After a program specification, the program goes through a phase of design. A design phase, I mean, it's like maybe the phase of an architect in buildings. You are coming up with a plan of how the final thing should look like. So here in programming, you develop what we call algorithms under design phase. An algorithm is just a set of steps that should be followed to solve a problem. So it's a step-by-step approach to solve a problem. So you develop algorithms, and these algorithms may be presented in different forms. You can present them using pseudocode, or you can present them using flowcharts. We are going to look at how we present these algorithms later using pseudocodes and flowcharts in later units. But this is a phase where you actually come up with a design of your program. You are translating the requirements into a design ready for the development, how your program will look like. So it is generally one of the lengthy stages. Design. Because you come up with a design, you find out that maybe that design is not good enough, you can restart all over again. So you put a lot of creativity also under design. To come up with a very good design, it requires creativity. You try to come up with a maybe first design and try to critique it and try to perfect it, and finally may come up with something that will really work. So you come up with one algorithm, you look at that algorithm and see whether it's doing what you want it to do in a better way, or if it doesn't, then you discard that one and start all over again, or you modify that one to come up with a better algorithm. So that is all that is supposed to be done under design. Apart from that, we have now the phase of coding. When a program has been designed, it's time now that it goes into the hands of coders. So the coders would identify a programming language which is more appropriate. As we saw, there are different types of programming languages and there are different styles of writing it. So maybe the problem at hand may be better done using one style of writing a program, and in this stage you identify a program that should, a language that should do that. So you identify an appropriate language and you start now translating the design, the algorithms that you created into a specific language. You may use some components which are already existing. Not everything will be created from scratch. So there are libraries that you can use, libraries for different languages. Each and every language has got some libraries, some existing code that you can just use, including your program, or in your program, and build upon it. Also, there are some programming frameworks that we may use. Programming frameworks try to simplify the development process in a certain language, or it tries to impose some styles of writing some program in a certain language. So there are so many programming languages, frameworks out there. So if you pick a programming language, you may also want to explore the frameworks which are there, and maybe you can use a framework to speed up the development time. So we are trying to, at the end, to come up with what we call a quality code. And a high quality code can be achieved through the use of comments. So when you are writing your program, you have to make sure that you include some comments. We are going to see how this is done in C++. And you have also to use meaningful identifiers. Try to use identifiers that are making sense. Sometimes programmers may go crazy and use identifiers that are only making sense to them, but we are not writing programs for ourselves. We write programs so that other programmers should be able to understand. So when you are naming anything in programming, make sure that you are using a meaningful identifiers. We are going to look at this in detail when we start the lab sessions. And also, write readable code. There are issues to do with indentation, as we're going to see, and the use of white spaces. Your program should be legible enough. When somebody has that program or that code, should be able to follow through it without problems. So, and these other things, you may wish to go and read about offensive programming, but it's also another way of achieving high quality code. When it has met, or a program has met a challenge or an error, there should be a way of not continuing with the execution of a program, but the program should hold gracefully, and so many other things that we can use to achieve a high quality code. So, to also make sure, because in most cases when you have such a program that you are maybe building, it will not only be one person doing it, it will be a team, maybe 2, 3, 4 people working together. So there should be a way of collaborating with each other and making sure that what you are coming up is something that will be of good quality, something that what somebody has done or written is not going to be overwritten by another one. So there are tools that are used to achieve that. So in coding, you can use Git as a tool that should help in versioning of your code, as well as GitHub for collaboration. So you can have a team working on the same program, everybody writing a piece of it, and you'll be able to work together without problems using these tools. So these are first 3 phases: specifications, design, and coding. See you in the next video.